Our next unit is probability, and before we look at probability, we need to be able to understand how many outcomes are possible for different events. So we're starting off today with a topic called sample space. One way to determine sample space for an event is to use a tree diagram. So for example, if you flip a coin twice, my first tree diagram here shows the outcomes possible when you flip a coin twice. On the first flip, you could get heads or tails. If you get heads the first flip, you could get heads or tails the second flip. And then if you get tails on the first flip, you could get heads or tails on the second flip. So it's a visual way to look at the possible outcomes. Another way to look at the possible outcomes, or sample space, is to list them all out. You can use your tree diagram to do that as well. So looking at the first branch, our first outcome is heads and then heads. Our second outcome is heads and then tails. Or we could flip tails, then heads, or we could flip tails, then tails. So the sample space is listing out all possible outcomes for each event. Our first example, our events are rolling a die and flipping a coin, and then we will also count the total number of possible outcomes. So when you roll a die, there are 6 possible outcomes. You could get a 1 through 6 on the die. And then after you roll the die, you flip a coin. There are 2 possible outcomes on the coin, heads or tails. So branching off of each number will have heads or tails for the possible outcome on the die. All of these are H then T because I'm trying to squeeze it all in. Some of those H's don't look very clear. So H for heads, T for tails. So that is the tree diagram that represents what we could get when we roll a die and then flip a coin. The sample space is listing out all possible outcomes. So we could roll a 1 and then flip heads. We could roll a 1 and then flip tails, and so on. We could roll a 2, flip heads, 2, flip tails, 3 heads, 3 tails, 4 heads, 4 tails, 5 heads, 5 tails, or 6 heads, 6 tails. So either looking at the tree diagram or looking at our sample space, we can determine the total number of outcomes is 12. Example 2, we've already got the tree diagram listed out for us for possible combinations for a lunch. We're going to write out our sample space and then determine the total number of choices. So our sample space would be you could get a ham sandwich with a salad and then milk, or you could get a ham sandwich with a salad and then soda. You could also get a ham sandwich with chips and milk, or a ham sandwich with chips and then soda. The final side option would be ham sandwich with a cookie, and I just realized I can't use a C again, so I'll use a K for cookie and milk, or a ham sandwich with a cookie and soda. So those are all of the possibilities ordering a ham sandwich. That's the sample space for ham sandwich only. We would repeat that for turkey and roast beef, as I believe that you probably have this concept down at this point. In order to save your time in the video, I will not go through that, so you could jot down the sample space for turkey and roast beef on your own. And then finally, we'll figure out the total number of choices. So for ham sandwich alone, we have 6 choices. We also have those same 6 choices with a turkey sandwich instead, and 6 choices with roast beef. So adding those all together, the 6 plus 6 plus 6, gives us a total number of 18 possible lunch combinations that we could order. That's our lesson on sample space. So here you go, you've got a tree diagram for the possible outcomes if a family decides to have 3 children. So list out that sample space and then determine the total number of outcomes.